All right, we're done with y equals mx plus b for a little bit. Now we're going to get back to solving equations. Here's an easy one. X plus 3 equals 7. Obviously, x equals 4. However, if we did not know what the second number was, it was another unknown, say y. Now we can't solve this. So if I said, what do x and y equal? Some of you might say 4 and 3. X is 4, y is 3. And you're right, that's one possible answer. Somebody else might say x is equal to 5, y is equal to 2. Somebody else might say x is equal to 1, y is equal to 6. You're all correct. The point is, there's an infinite amount of variations here because you could also start doing decimals. You could say x is 5.5 and y is 1.5. So we could just list possible answers for the rest of our life and never list them all because there's an infinite amount of possibilities. There's no way to know for sure how much x is and how much y is when you have two variables, two unknowns in a problem. You can only figure out an unknown if it's only one unknown, like x plus 3. Now we know for sure x was 4. So how are you supposed to figure out what x and y are? If there's two unknowns, you have to introduce a second equation. Now we have what's called a system of equations, and that's what this standard is. Systems of equations. And that means two equations because there's two unknowns in each equation. But then we can figure out what those unknowns are. So let me give you a real life example to make this hopefully make sense to you. We've got two cars going through a drive-through ordering burgers and fries. So B is going to stand for burgers, F is going to stand for fries. Car 1 goes through the drive-through, orders 4 burgers, 2 fries, and they pay a total of $10. Car 2, right now that's not enough information. We don't know how much the burgers or fries cost because x plus y equals 7 is the same thing here. The burgers could be $1 each. They spent $4. The fries could be $3 each. That's 6. That equals 10. So the burgers could be 1. The fries could be 3. This is just like x plus y equals 7. There's an infinite amount of answers. Two unknowns in an equation. You might be looking at this and saying, that's not an equation. Well, we can build that into an equation. We could say 4b plus 2f is equal to 10. We have two unknowns, a B and an F. How much does one burger and how much does one fry cost? We don't know. Not enough information. So we introduce a second car. We get more data. Now we can figure it out. The second car bought 4 burgers for the same price that burgers cost these guys, 3 fries for the same price that fries cost over here, but they spent $11. So let's build an equation for that. 4 burgers plus 3 fries is equal to 11. Now we can figure out how much it costs for 1 burger and 1 fry. And that's the ultimate goal here, to solve B and to solve for F, which means how much does 1 burger cost, how much does 1 fry cost. Well, to do that, you have to subtract these two equations from each other. It doesn't matter if you do car 1 minus car 2 or car 2 minus car 1. It's easier if you put the one with the bigger numbers on top. So when you subtract, you get positive numbers. So the bigger numbers were in car 2, so I'm going to move car 1 underneath before I subtract. So there you go, it's underneath. Now I'm going to subtract. And the key to subtracting is that one of your variables has to be the exact same, so that when you subtract, it disappears. And right now we have the exact same amount of burgers, 4 burgers in each car. So if we subtract cars, 4 burgers minus 4 burgers is 0 burgers. The burgers are gone. 3 fries minus 2 fries is 1 fry. You don't need the 1. 1F is just F. 11 minus 10 is 1. So 1 order of fries costs $1. It's $1 for a thing of fries. So we're halfway there. We know how much our fries cost. $1. We can use that now to figure out how much the burgers cost in either one of these equations, either one of the cars. Let's say car 1. Car 1 spent $10 total. They bought 2 fries. So if fries are $1 a piece, that means they spent $2 on fries. They bought 4 burgers and they paid $10. So that's what we have for our equation so far. We substituted in the 1 for fries into the first car equation. So they spent $2 on fries. They must have spent $8 on burgers because they spent $10 total. You just solve for B. Subtract 2 to the other side, and you get 8. 8 burgers or I'm sorry, 4 burgers cost $8. So how much is it for 1 burger? Well, you divide by the 4 and you get a 2. 1 burger costs $2. Does that work for equation 2? $2 a burger. They bought 4 burgers. That'd be $8. $1 per fry. That'd be $3. Sure enough, $11. So it works. So that's how you figure out 2 unknowns. Is you got to have 2 equations and subtract them from each other. Well, sometimes it's going to happen where the letters, your unknowns, aren't going to be the same. Like last time it was 4 burgers for each car. Now they're buying different amount of burgers and different amount of fries. So let's build our equation. 6 burgers plus 4 fries equals $26. And then over here in car 2, 12 burgers plus 5 fries, and they spent a total of $46. Now if we subtract, none of these are going to cancel out, and we're still going to be left with 2 variables, and that doesn't help us. 2 unknowns, you can't solve the equation. We got to get rid of one of these unknowns. We have to get rid of one of these variables. So to do that, we're going to have to change one of these equations, meaning we're going to have to double that order or triple that order, whatever it takes to get either the burgers to match up or the fries to get match up. Basically, we're going to multiply the whole equation by a number. We're going to distribute, in this case, a 2. We're going to double car 1 order. Why did I do that? Because if you double the order of car 1, now you have 12 burgers, just like in car 2, and that's what we want. We want either the burgers to match up or the fries to match up. It's hard to multiply 4 by something to get it to equal 5. That would be a decimal. We don't want to mess with decimals. Let's stick with whole numbers. So let's double car 1 to get the burgers to match up. So now car 1, if we double it, now they had 12 burgers and they had 8 fries and they spent $52. 52 is twice as much as 26. Car 2's order stayed the same. They still got 12 burgers, 5 fries, and spent $46. Now we can subtract because now we have the same amount of burgers. It doesn't matter if the burgers are the same or the fries are the same. As long as one of them is the same, then you can subtract and it'll be gone. So our burgers are going to be gone. 12 minus 12 is 0. We're going to be left with 3 orders of fries when we subtract our like terms. And we're going to be left with $6. 52 minus 46 is 6. So now we know that we spent $6 on 3 orders of fries. That means each order of fry was $2 each. 6 divided by 3 is 2. So we're halfway there. Our fries were $2. Now we start over with one of our equations, one of our orders here. And let's just go car 2, since it's easier, it's on the bottom, easier for me to work with. So car 2, they bought 5 fries at $2 each, so that must be $10, right? 5 times 2. So they spent $10 on fries. So all I did was substitute in the 2 for F, and I got a 10. So they spent $10 on fries. They spent $46 total. So if they spent 10 on fries, they must have spent 36 on burgers, because 36 plus 10 is 46. And you'll see that when you solve for B, you subtract 10 to the other side, and sure enough, 46 minus 10 is 36. 12 burgers cost $36. So how much does 1 burger cost? You have to divide that by 12, because you bought 12 of them. Divide by 12, and you get 1 burger is equal to $3. 36 divided by 12, and now we're done. Our burgers were 3, our fries were 2, and it works. 6 burgers at $3 a piece, that's 18. 4 fries at $2 a piece, that's 8. 18 plus 8 is 26. Over here, 12 burgers at $3 a piece, 5 fries at $2 a piece, that's 10. 36 and 10 is 46. Boom, it's good. So the lesson here is subtract the 2 equations from each other after one of the variables is exactly the same. So sometimes you'll get lucky and the equation will give you the same amount of x's or the same amount of y's, and you can just get straight to subtracting. Other times you have to double one of them or triple one of them first to get them to match up, and then you can subtract.